Thanks to the World Wide Web, I've been following the progress of Cassini-Huygens from the time it was launched several years ago. As you know, I have more than a passing interest in Saturn. Cassini is going to come within a little over 1,000 kilometers of Iapetus.
Cassini has also had its first close look at Iapetus, a satellite with one face as black as asphalt and the other as white as newly fallen snow. Bisecting Iapetus's dark side, Cassini has discovered an incredible ridge of ice that runs over 800 miles along the Moon's equator and contains mountains 3 times as high as Everest. Elsewhere on Iapetus, Cassini's cameras capture the aftermath of a huge landslide that partially obliterates the floor of a great basin, ringed by walls of ice over 9 miles high. Later flybys of Iapetus will bring us views up to 100 times sharper.
More than 40 years later, I can't remember why I placed the Saturn monolith on Iapetus. At that time, in the early days of the space age, Earth-based telescopes couldn't show any details of this celestial body. This is a particularly exciting moment for fans of 2001, of Space Odyssey, because that's where the lone astronaut, Dave Bowman, discovers the Saturn monolith, which turns out to be a gateway to the stars. Saturn's science projects are tremendously important for our understanding of the solar system.
Pac-Man has been spotted orbiting Saturn. The Cassini science team took infrared pictures of one of Saturn's moons and found that the temperatures on the surface look a lot like the 80s arcade character.
Look, it's Pac-Man. Well, not really, but NASA spotted the shape on thermal data from Tethys, one of Saturn's moons.
This is actually the second time Pac-Man has been spotted around Saturn.
It's something big, something strange, and something never seen in the universe before. Saturn, the solar system's most bizarre yet beautiful planet, has just gotten even more mysterious. In 1979, the Voyager spacecraft showed a perfect geometric form over the North Pole. In October 2006, the Cassini craft found that it is still there.
It's just bizarre, and it sits there kind of still. It doesn't move with the planet. The pole, there's a hexagonal feature, a six-sided polygon that encircles the pole at about 78 degrees north latitude. And it's sitting there as a set feature.
The hexagon is similar to Earth's polar vortex, which has winds blowing in a circular fashion around the pole. Saturn's vortex can fit 4 Earths inside of it and extends 60 miles deep into Saturn's clouds.
And what's more bizarre, Voyager saw little tiny clouds going around at about 100 meters per second, which is about 200 miles an hour, going around this racetrack. People thought, well, maybe it's just a temporary thing. How could this stay there? It's been there now for at least 20 years, and we're going, what is this?
Richard C. Hoagland talked about the hexagon 10 years ago, maybe 15, Richard, wasn't it?
Do I get the second hour?
You not yet, but you'll get back.
It was 15. 15 years ago, I had the privilege of standing in the Dag Hammarskjöld Auditorium, which, by the way, has 195 seats, which I thought was kind of interesting. And I had to do 2 back-to-back presentations because there was not enough room, and we had to do 7 hours total, which we taped. And in fact, that old tape is available as a DVD from the Enterprise mission. If you go to our Enterprise mission website, the link is at the top, and I'll give out an 800 number in a little while if George lets me.
Yes, he will. Okay.
But the most remarkable thing is that this was taken, this image of this extraordinary geometric figure has been known since 1980, since the first Voyager flyby. What was astonishing to everyone then, and what is astonishing to me now, is that it's still there. This is what all the excitement is about, because the new Cassini mission, which is this incredible Greyhound bus-sized spacecraft that has Saturn now orbiting, not flying past, but orbiting, took some really amazing 12 days of infrared photography, far infrared, which is the heat radiation coming up from the interior of Saturn, over a 12-day period, and they made this movie, which is going to be on the extensive, article that I'm working on right now for the Enterprise Mission website, which is not quite ready because, George, you kind of, got to me a little sooner than I thought you were going to.
I couldn't wait. I told you earlier when this thing broke and you and I started conversing, I was going to look for the hole to get you in fast.
So we have a hole on Thursday night, okay?
So we have the hole.
Anyway, by tomorrow I'll have this probably posted, and there's some amazing photography, synoptic, different wavelengths, different levels. This thing, George, is kind of like the Rosetta Stone. It's the key to so much of what I've been discussing with you and Art going back, before I did the UN, about hyperdimensional physics and how the solar system really works. And I'm really kind of amused to see the NASA people saying things like, well, we can't understand it.
Yeah, it's
just baffling.
It's bizarre, they say. But I've got to ask you, Richard, what the heck is it?
Well, first of all, the clouds we're looking at are not solid features. Saturn is one of the gas giants, so there's no solid surface. You're not looking at mountains or valleys or whatever. You're looking at an incredibly big dense, fluffy atmosphere. And this set of hexagonal lines, 6 sides, perfectly straight, centered on the pole with an interior hexagon inside the outer one, is about 25,000 kilometers across. You could put 4 Earths side by side across this thing and just touch each edge, each side. And it's made of clouds. It's made of ammonia clouds. And what's really cool is to see in some of the infrared shots that just as we saw in 1980 with the Voyager visible light imagery, we're seeing that the clouds are racing backward, George, along the edges of this hexagon at over 300 miles an hour. And they're making the turns, the 60-degree turns at each of the corners. I mean, this is just so phenomenal for a fluffy, insubstantial atmosphere of gases and clouds. I mean, no one can imagine, certainly not at NASA, how this thing works. Well, I did at the UN 15 years ago, and I stood up there and I laid it out. It's all about hyperdimensional physics.
I mean, it is absolutely mind-boggling to think that a cloud pattern on top of a pole of a planet could have that kind of shape to it and stay there for so long.
Well, that's the really cool part. Nobody except us apparently expected this thing would persist. I mean, when we first saw it, I realized that it was another part of the puzzle, the connecting the dots with the whole hyperdimensional model, which predicts very nicely why you have huge cyclonic features near the equator of these planets at 19.5 degrees, why you have volcanoes with lava coming up from the outer core of the Earth on Earth at 19.5, which is the big Hawaiian volcano, why you have the largest volcano in the solar system, ancient and fossilized, and a huge pile of rock on Mars at 19.5, because rotating planets are literally able to create force structures inside. These are standing wave patterns, which allow for energy to come up at these preferred points. Mm-hmm. And one of the signatures is 19.5. The other, if you have the right dye in the stream so you can see it, like the atmospheric ammonia in Saturn's atmosphere, is this incredible hexagonal feature precisely located around the north rotational pole of the planet Saturn.
Will it ever dissipate, Richard?
No. It is permanent. As long as Saturn exists, this will be there. So it's going to be there for a lot of study during the Cassini mission, and I imagine during the extended mission they will crank the orbit up again into this quasi-polar orbit, which is at a very high latitude looking down on the north hemisphere, which, by the way, you can't see the northern hemisphere right now because it's in darkness. Saturn is tipped about like the Earth. It's tipped about 25 degrees to its orbit. We're tipped 23.5. And so the northern hemisphere of Saturn, particularly the poles, is in winter right now. It's not going to get sunlight for another couple of years, so they can only look at this thing and monitor it with the infrared, and the infrared is penetrating deep in the atmosphere, although on a planet which is 60-some thousand miles across, 50, 60 miles is not very deep, but it's deep enough for them to see, again, they're not expecting this, that this thing has multiple layers, that the hexagons go down, kind of like one of those nested Chinese puzzle boxes.
Yes, exactly.
And it goes down in toward the core of the planet, which, of course, is intrinsic to our model, because all of this geometry, all of these standing waves, all of this patterning is due to the energy coming up from the center of Saturn, which is, in fact, coming in from another dimension,
All right, so we are counting down on what's being called an earth-shattering announcement out of NASA. Experts calculating and speculating.